Hi everyone, welcome to my channel. This is Leo and let's do some more Leetcode problems today. Today's problem is called top k frequent elements. We were given an integer array nums and an integer k. Return the k most frequent elements. You may return the answer in any order. So let's take a look at an example here. So basically we are not given any other information about the nums array. So basically we can see from this example that it contains some duplicates. Okay, so in that case, if we want to find the top two most frequent elements, we have to deduplicate because we're not going to return like the first two ones to be the top k frequent element. We want to return the top k distinct frequent element. Okay, and here we have another one, which is the nums array is only one element, and top one element will be just one. Okay, so this could be pretty simple because when we think of top k something, we naturally think of a heap. Okay, and after my explanation, we are going to find the distinct elements and put them into the output. Okay, so basically we can record the frequency of each element and we order it in terms of their frequency and find the top k elements. Okay, so this should be pretty simple. So let's code it out. The first thing to check is, like in example 2, if k equals to nums.length. In this case, we're just going to return nums. Okay, so that means we have the most frequent element here. Okay, so other than that, we can initialize a heap to store the distinct top k frequent elements. But before that, we need to know the frequency of each element. So we're going to use a map, and it's going to record the frequency of each element. Okay, and for I equals to 0, or maybe we can just iterate through the nums array. Okay, so frequency will put n frequency get or default and 0 plus 1. Okay, so in this case we have the frequency of all the elements. Okay, and now we can initialize a heap. We initialize a heap to record the top k frequent elements based on their frequency. Okay, so are we going to use a min heap or max heap? So for this question, we're going to find the top k frequent elements. That means high frequency, from high frequency to low. So in this case, we're going to use a min heap. Okay, that's going to be more efficient. So we're using a priority queue, and for A and B, we have a lambda function here. We're going to compare its frequency in the frequency map. Okay, so basically the one that with the lower frequency will have higher priority. Okay, and after that we can iterate, not the original nums array, we're going to iterate through the frequency key set. Okay, so for each key we have a corresponding frequency. We're going to store them in the heap, where we keep the size of the heap to k. If we have something more than k, we're just going to pop out. Okay, so that we have the top k frequent elements. Okay, so heap.offer n, and once the heap size is larger than k, heap.poll, that will be it. That gives us a size k heap. So after that, everything was stored in the heap. So we can construct the final result. It's going to be heap.size, okay? Or you can use k. Yeah, basically the same thing. And since we're constructing a new array, we're going to use a pointer. So while heap is not empty, we can just use result I to get heap.poll. Okay, then we can return result. Let's see. Okay, perfect. It gives us the right answer. So in terms of complexity, we're traversing through the array. This gives us an on, and we have a heap. We iterate again, and we do the percolate. So for this, it will be a log k, and since we're performing n operations here, so the dominant time complexity will be n log k. And for space complexity, we're using a frequency map, which could be n, and we have a heap, which can be k. So that would be the maximum of n and k. Is that so? Yeah. So if we have all the elements in the array with the same frequency, we have a map of size n. And if we want the top 302, which is less than n, we will have a heap of size k. So that's going to be the maximum of n and k. But basically, we can initialize it to k. Okay? We can say it's okay. Space complexity. Okay, perfect. It passes all the test cases. Thank you so much for watching, and we have another solution for this problem, so stay tuned. I'll see you in our next video. If you liked the video, please like and subscribe to my channel. Bye.